Okay, so our key here, when we look at the difference between multiplying fractions and adding fractions, is when we're multiplying fractions, we don't need a common denominator. We just multiply numerators, multiply denominators, and that gives us our result. When we want to add fractions, we can't just add numerators and add denominators. We need them to be the same denomination. Thank you, Natalie. I appreciate that. And to change 1/2 and 1/3 into numbers that have a common denominator, we're going to use 6 as our denominator. We're going to rewrite those as equivalent fractions. 1/2 we rewrite as 3/6. 1/3 we write as 2/6. And now that they have the same denominator, we can add them. And to add those, we keep the denominator the same and we add the numerators. Essentially what we're saying is I have 3/6, I add 2 more 6, so altogether I have one more. Multiplication of fractions is subtraction. If we wanted to do 1/2 minus 1/3, the same rule holds. We're going to have to get a common denominator before we can subtract. Here again, we're going to rewrite these as equivalent fractions with 6 as our denominator. If we multiply the denominator by 3, we have to multiply the numerator by 3. If we multiply the denominator by 2, we have to multiply the numerator by 2. And so now I have 3/6 minus 2/6. Similar to what we did with addition, I have 3/6, I take away 2/6, that leaves me with 1/6 as an answer. Just a coincidence that these two answers happen to be the same. Don't read anything into that. The key here is multiplying, we don't need a common denominator. Adding and subtracting, we do. Any questions on that before we move forward? Awesome. Numbers. If we look at a mixed number, and first we should establish what a mixed number is. A mixed number is a number that has a whole number part and a fractional part. So a mixed number has a whole number part, fraction part. Many of you are probably very comfortable with a fraction of as an improper, but I want to walk through something that you know why the shortcut works. Because there is a shortcut to rewrite this mixed fourths could be rewritten also. Y'all see my writing? Because I'm not. After the word fraction, I haven't seen any of my writing pop up there. Okay, good. Now I can see it. All right. We'll just stick with this one. So that 3 plus 1/4, I can rewrite as 1 plus 1 plus 1 plus 1/4. Let me know if you see something that doesn't make sense or where it came from. All right. Thanks, Stephanie. Oh, okay. So we lost audio. Boy, we're having a rough one. Okay. Now we'll go from here and y'all let me know if we have any trouble. I don't anticipate any more. Okay. And then these ones I could rewrite. They're written as whole numbers right now, but we're going to rewrite those as fractions. And if I rewrite 1 as a fraction, I want to use 4 as my denominator. So that 1 is going to become 4/4, and this one is going to be 4/4, and the third one is going to become 4/4, and then that 1/4 is still there. So what I've done is I've said 3 1/4. I could write that as 3 plus 1/4, which I could rewrite as 1 plus 1 plus 1 plus 1/4. And that I could rewrite as 4/4, 4/4, 4/4, and 1/4. Those all have a common denominator, so I can add those together, and it's 4, 8, 12, 13 fourths. This is what's known as an improper fraction. It's called an improper fraction because the numerator is bigger than the denominator. Really, there's nothing wrong with it. Improper kind of gives the idea that there's something bad or wrong, or we don't like these, but that's not true at all. Improper fractions are just fine. There's nothing wrong with them. We'll use them all the time. So it's perfectly okay to write them. They're just called improper because the numerator is bigger than the denominator. That's all. The shortcut to get from 3 1/4 to 13/4, if we want to take a mixed number and rewrite it as an improper fraction, many of you probably know this. I would have you tell it to me, but it's pretty clumsy to say to type in there. But if this doesn't make sense, you let me know. But we start down here at the denominator and we multiply by the whole number part. So 4 times 3 is 12. And then we add the numerator. So 4 times 3 is 12, plus 1 is 13 fourths. And essentially what we've done here is this 4 times 3 is really just these 3 guys right here. And then we're adding the extra 1 in. So essentially we're taking this whole process and just doing this shortcut where we multiply denominator by whole number part, add numerator, and that's how we convert a mixed number into an improper fraction. It can be useful sometimes to convert it to an improper fraction. If we want to add mixed numbers, we have a couple of different ways we can do this, and we're actually going to look at both ways. The first way is convert those to improper fractions and then add those. So we'll do that first. So if I have 2 3/4, and I want to add that to 1 5/7, one approach I can take is convert both of them to improper fractions and then add them. So you let me know if you see something that doesn't make sense. 4 times 2 is 8 plus 3. With this will be 11 fourths. 7 times 1 is 7 plus 5. It'd be 12 sevenths. And now I'd like to add those, but they don't have a common denominator, so I'm going to have to get one. 7 and 4. Anybody got a suggestion for me? What's a good choice for a common denominator for 7 and 4? Perfect. I'll take it, Courtney. 28. Leslie's probably right there with you with 28. We're going to use 28 as our common denominator. And over here on the left, if we multiply the denominator by 7, we have to multiply the numerator by 7. Over here, if we multiply the denominator by 4, we have to multiply the numerator by 4. 4 times 12 is 48. And now I'm going to add those two together. I have a common denominator, so I can add them and have 28. And then 77 plus 48 on top is 125. Since I started with mixed numbers, I'm going to go ahead and finish with a mixed number. So while there's really nothing wrong with 125 28ths, since we started out adding mixed numbers, we'll go ahead and finish with a mixed number here. And what I'll need to do is, how many times will 28 go into 125? Remember, this is really just 125 divided by 28. That's kind of what that fraction means. So I'll divide by 28, and I get 4.5 4, 6, 4, 2, on and on and on. We're not really interested in the decimal part here. We're interested in the whole number part, and that's going to be 4. And this goes back similar to the kind of things we did when we were converting numbers in other bases. We have 4, and then we have to figure out how much is left. Well, that 4 times 28 will take care of, let's see, 112 of this 125. And so then 125 minus 112, that means there's 13 left over. And so what I end up with here is 4 and 13, 28. So we've added those two mixed numbers. The first thing we did was convert them to improper fractions, get a common denominator, add them, and then we had to turn that back into a mixed number. And the way we did that was we divided first and got 4 point something. What we really care about is 4 gave us 112, so we had a remainder here of 13, and that remainder is what winds up in the numerator of our fraction at the end. That's one way to add these two mixed numbers. Another way that you might like better is we're not going to convert them to improper fractions. Instead, we're just going to add them up. If I wanted to add 2 and 3/4 plus 1 and 5/7, another way I could go is I could add the whole number parts and then add the fraction parts. That's what we'll do in this approach. I could do 2 plus 1, that's 3. And then if I want to add 3/4 and 5/7, I'm going to need a common denominator. We kind of just did this, so we can see that 28 is going to be our common denominator. If I multiply by 7 on the bottom, I have to multiply by 7 on the top. We multiply by 4 on the bottom, we have to multiply by 4 on the top. And then I'll add those together. 21 28ths and 20 28ths will be 41 28ths. Since that's bigger than 1, we don't want to leave that improper fraction there. This 41 28ths, well, really, that's just 28 28ths plus 13 more 28ths. And the reason I did the 28 28ths is because this is just 1. And so now what I've got is I have my 3 over here, my 1 right here, and my 13 28ths. Putting all those together, that's 4 and 13 28ths. Same answer we got the other way. It better be. I think if I had a personal preference, it would be this way, which is why I saved it for last. But if you like converting them to improper fractions first, you absolutely can. Let me know if you have questions about this before I have you try one. Okay. Add those two mixed numbers, 4 and 3/8 plus 2 and 2/3. I'll set up a poll for this one. So you can either do this one by converting them to improper fractions and then adding, or add the whole number part, add the fractional part. Either way, when you add those fractional parts, you'll need a common denominator. I'll give you a little more time on this one. Let's go another 15 seconds and then we'll talk about it. Okay, not unanimous, but strong agreement. We'll go back and take a look at how to do this one. I'm going to do it by adding the whole number parts, adding the fractional parts, but if you want to see it the other way, you can let me know. So we have 4 3/8 that we want to add to 2 2/3. I'm going to add the whole number part. 4 plus 2 is 6. And now I want to add those fractional parts, but they don't have a common denominator. For 8 and 3, I could use, let's see, 16's no good. 24 is, so we use 24. So 8 will go into 24 3 times. So if we're multiplying the denominator by 3, we have to multiply numerator by 3. 3 will go into 24 8 times. So if we're multiplying denominator by 8, we have to multiply the numerator by 8. 2 times 8 will give us 16. What we've done here is rewrite 3/8 as an equivalent fraction, 9/24. And rewritten 2/3 as an equivalent fraction, 16/24. We do that so that we can add them since they have a common denominator. Then we'll add those. 9/24 and 16/24 will be 25/24. We don't want to leave that as an improper fraction, so we can rewrite that as 24/24 plus 1/24. This 24/24 is just 1, so I wind up with 6 plus 1 plus 1/24. And when I add those together, I get 7 and 1/24. And that was our most common answer there. But if anybody has any questions about that, don't hesitate to let me know. Okay, let's look at subtraction. Subtraction of mixed numbers. Here we're going to use this very similar approach to what we just saw with addition. We're going to have 5 3/5 minus 2 6/7. I want to subtract those. You might think, well, we can subtract the whole number part and then go worry about the fractions. But honestly, we're going to do it the other way. We're going to start over here with these fractions, and there's a reason for that. If I want to subtract those, I need a common denominator. For 7 and 5, I'm going to use 35. If we multiply the denominator by 7, we multiply the numerator by 7. So 3 times 7 is 21. If we multiply the denominator by 5, we have to multiply the numerator by 5, and 6 times 5 is 30. I mentioned we were going to start with the fractions, and what I would like to do is do 21/35 minus 30/35. Unfortunately, I can't do that because I can't take 30 away from 21. So what I'm going to have to do here is I'm going to have to borrow. I'm going to borrow from this whole number. That's going to become a 4, and I'm borrowing 1. How do I want to write that 1 that I've borrowed over here? What is it that is the way that I want to write it? I don't want to just put, okay, I've added 1, because that's not what's happened. What have I done? Perfect, Natalie. That's excellent. Very good. What I've done here is I have borrowed 35/35. So now my new fraction on the top here It's not 21/35 anymore. Now my new fraction on top is, let's see, 21 plus 35, that's going to be 56/35. Just to pause for a second. Yeah, that's exactly right, Leslie. Just to pause for a second. What I started with was 5 and 21/35. Now what I'm saying is I have 4 and 56/35. Those have the exact same value as each other. This is very much like when we were doing addition and subtraction in other bases. Here, we're borrowing 35/35 because that's what we need to work with. And now I'm going to subtract 56/35 minus 30/35. And when I do that, I'll end up with, let's see, 56 minus 30, that'll be 26/35. And that's okay. And over here, I can do my 4 minus 2, which is just 2. And so I end up with 2 and 26/35. The key here is this borrowing step. If we're unable to subtract what we've been given, we're going to have to borrow, and we have to borrow carefully based on what our denominator is. Are there any questions on that before I have you try one? Okay, here goes. Subtract those two mixed numbers, 7 1/4 minus 4 2/3. And I'll set up a poll for this one. Let's go another 20 seconds on this, and then we'll talk about it. Okay, let's see where we are. Okay, a little bit split on this one. So let's go back and take a look. We have some agreement, but we are a little bit split. So let's make sure we're being careful here on this one. We only had 2 answers that were selected, so that's good news. And if you see something that doesn't make sense, you're not sure where it came from, make sure you let me know. So we have 7 1/4 minus 4 2/3. So that's what we're going to subtract here. And I'm going to start with those fractions. And I have 4 and 3 as my denominators. So I'm going to use 12 as my common denominator. If we multiply denominator by 3, we multiply numerator by 3. If we multiply denominator by 4, we have to multiply numerator by 4. And as much as I would like to 3/12 minus 8/12 is something I can't do. So I'm going to have to borrow. I'm going to have to go over here and I'm going to borrow from this 7 and make it a 6. And what I'm borrowing is a 1, which is 12/12. So what I've done here now is I've rewritten my mixed number as 15/12 to go with 6 and 15/12 has the same value as 7 and 3/12. But for this particular problem, oh, all right. Let me back up then, Courtney. Let me back up. Okay. Let's start here. What I've done is I've taken this, I would like to do 1/4 minus 2/3. In order to do that, I need a common denominator. So I'm going to use 12 for my denominator. I'm going to rewrite 1/4 as 3/12 and rewrite 2/3 as 8/12. Is that much okay? Great. Okay. Now what I would like to do, looking at my fractions here, is I'd like to do 3/12 minus 8/12. But that would give me a negative number, and I don't want that here. So I can't subtract 3/12 minus 8/12. So what I'm going to do is I'm going to trade from this whole number over here. That whole number of 7, I'm going to reduce that down to 6. What I've done is I've borrowed 1 that I'm going to use over here with my fractions. So for right now, what I'm saying is that 7 and 3/12 is the same as 6 and 3/12 plus 1. Is that okay? And I'm sure you're not the only one having this question, Courtney, so you're just the voice of several others. Awesome. Very good. Okay. Now, I want to combine these two. 3/12 plus 1, that doesn't do me any good here. What I need is something with a denominator of 12. So this 3/12 plus 1, I'm going to rewrite that as 3/12 plus 12/12. So this 1 right here, I'm rewriting it as 12/12 so that I can add it with my 3/12. Is that all right? Perfect. And now I can actually add those and have 15/12. In this problem, I started with 7 and 1/4 as my numerator. That 7 and 1/4, because I wanted 12 as a denominator, I rewrote that as 7 and 3/12. And then because I wanted to subtract, that 3/12 was no good. This 8/12 down here was too big. I couldn't subtract anything. So I borrowed 1 from that 7 and put it over here in the fraction part. Now I wanted to add that to the 3/12, so I call it 12/12. I add those together and now it's 15/12. And what I've done is I took my 7 and 1/4 and I rewrote it as 7 and 3/12. And now what I have is 6 and 15/12. In essence, what I've done is I've rewritten this in a different format that was convenient for me for this problem. 7 and 1/4 is the equivalent to 7 and 3/12, which has the same value as 6 and 15/12. Because this down here would really be 6 plus 12/12 plus 3/12, which is the same as 7 and 3/12. Awesome. Very good. Outstanding. If anybody else has questions, please don't hesitate to ask them. So now what I'm looking at is I have this 6 and 15/12 in the numerator. I have this 4 and 8/12 in the denominator. Now I'm going to do my subtraction with those things. I'm going to start over here with the fraction part. and do 15 twelfths minus 8 twelfths. That's going to leave me with 7 twelfths. And then over here in the whole number part, 6 minus 4 is just 2. And I end up with 2 and 7 twelfths. Oh, gotcha. Yeah, turning them into improper fractions isn't a bad thing, but the numbers can get really big and that can spin you around sometimes. So I would encourage this way, where you just borrow a 1 and you rewrite that 1 using the denominator that you've set up in the problem. Did this fix it? And for anybody else that might be having trouble, let me know if you're having trouble. Let me know if this fixed it. Oh, awesome. Fantastic. Very good. Very good. Okay, last week, we spent a little time looking at the greatest common factor. What we did was we did the prime factorization of a number, and then we found the greatest common factor by looking at what they had in common, where they overlapped. Today, we're going to use prime factorization again, but this time we're looking for the least common multiple. Least common multiple is the smallest number that these two numbers will go into evenly. So I need 45 to go into it. I need 60 to go into it. Factors, when we were doing the greatest common factor, these are always going to be smaller than your numbers. It could be equal to, but smaller, less than or equal to. Let me be a little more precise here. Factors, when we look for the greatest common factor, we're going to find something that's less than or equal to the numbers we've been given. In contrast to that, multiples, when we're looking for the least common multiple, it's going to have to be greater than or equal to the numbers we've been given. And at some level, that should make sense, okay? Because if we were to list the multiples of 45, then 2 times 45, then 3 times, okay, yeah, they're just going to get bigger and bigger and bigger. They're not going to get smaller. Same thing would be true if we listed the multiples of 60. They're just going to keep getting bigger and bigger and bigger. But instead of listing them all out and looking for what they have in common, what we're going to do is we're going to use the prime factorization again. We did that last time when we did greatest common factor. We're also going to use prime factorization to find the least common multiple. So prime factorization of 45, and you could do this in different ways. The first thing that I see here is 5 times 9. You might have seen 15 times 3. That's okay. And that 9 will break apart to 3 times 3. And so my prime factorization of 45 is going to be, let's see, I have 3 times 3 times 5. So there's my prime factorization of 45. 3 squared times 5. Let me know if you have any questions on that. We did those last week when we were looking for greatest common factor. I also need the prime factorization of 60. So let's see, 6 times 10. You might have seen something else, 2 times 30. Eventually you'll get to the same place. There's no right or wrong way to do these. So that's 2 times 3, and that's 2 times 5. And so I guess I have 2 squared times 3 times 5. So there's my prime factorization of 60. If we were looking for the greatest common factor, we look for what they have in common, what they both have, the overlap and the intersection, if I'm allowed to say that one, back from our set theory time. Now, with least common multiple, we want to join things together. We are going to keep the highest power of every term we have. This relates to union. We're going to join these things together. We're going to keep the highest power of every term we have. So as I look at these, I have 3 squared and I have 3 to the first. Well, that 3 to the second power is the highest power. So that's the one we keep. And then I have this 5 to the first, and I have 5 to the first. So I'm going to keep a 5 to the first power. And then I'm keeping everything. You don't have to be in both places. If you're anywhere on the board, we're keeping you. So this 2 to the second power, we're keeping that. And so the least common multiple of 45 and 60 is what I get when I multiply all these things together. 2 squared times 3 squared times 5. And I guess that'll be what, 4 times 9 times 5, which not sure what that is, but 4 times 9 times 5, 180. So the least common multiple of 45 and 60 is 180. That's the smallest number that 45 will go into, that 60 will also go into. When we do this, we find the prime factorization and we keep the highest power of every term. This is union. Greatest common factor was intersection. That's right, we keep them all, not the ones they have in common. For greatest common factor, we keep what they have in common. For least common multiple, we keep the highest power of everything. Be a little bit careful with that, because we have 3 squared and we have a 3. We're only keeping the highest power. We don't keep all 3 of them. We just keep 3 to the second power. I'm going to have you try one of these. Here goes. Find the least common multiple of 30 and 44. The way to do this is find the prime factorization of 30, find the prime factorization of 44, and then keep the highest power of every term. I'll go ahead and set up a poll for this one. So once you have the prime factorizations, we're going to use every term we have, we're going to use the highest power of it to get our least common multiple. And it's the smallest number that 33 will go into, that 44 will also go into. Let's go another 30 seconds on this, and then we'll do it together. Let's see. Okay. Strong agreement, spread all over all of them, which is interesting. But we do have a consensus on 660 here. So let's take a look at this one. So the first thing we'll want to do is find the prime factorization of each of those numbers. Remember, there's not really a right or a wrong way to find the prime factorization. We've got 30, and so maybe that's 3 times 10, and that's 2 times 5, and those are all prime numbers. So our prime factorization of 30 will be 2 times 3 times 5. Then our prime factorization of 44, that looks like 4 times 11, and that's 2 times 2. So it looks like I have 2 squared times 11. So I've got my prime factorization of each. We're looking for the least common multiple, so I want to keep the highest power of every term I have. I've got 2 over here. I've got 2 squared over here. I'm going to keep the highest power of that, which is 2 squared. I have a 3, so I'll keep that. I have a 5, so I'll keep that. And I have an 11, so I'll keep that. And so we wind up with 2 squared times 3 times 5 times 11. So that's 4 times 3 times 5 times 11, which is 660. And so that's our least common multiple. The 3 only occurred once, the 5 only occurred once, the 11 only occurred once. Those were easy. The 2 did occur in both places. We don't keep all those 2's. We keep the highest power that we have, which is 2 squared. As an aside, I'll just throw this in. If we were looking for greatest common factor, the only thing that they have in common is a 2. We weren't asked for greatest common factor here, but it would be 2, because that's the only thing they have in common, is a single individual 2. Okay, one more question I want to look at in section 3.3. There's not a ton in 3.3. 4.3 is a lot busier than 3.3. Here's a problem-solving type of question from 3.3. A bag of fertilizer seed blend is made up of 1/9 nitrogen and 2/5 grass seed. The rest is soil. What fraction of the bag is soil? The way we're going to go about this is figure out what fraction of the bag is not soil first. And as we look at this bag, it's 1/9 of it is nitrogen and 2/5 is grass seed. So we can add those together. We can do 1/9 plus 2/5. And what that's going to do is that's going to give us the fraction of the bag that is not soil. So there's nitrogen in there, there's grass seed in there, and everything else is soil. If we want to know what fraction of the bag is not soil, we just add the nitrogen and the grass seed together. Now to do that, we'll need a common denominator. 9 and 5. 45? There might be a better one, but I'm going to use 45. Let's see, we multiply the denominator by 5, so multiply the numerator by 5. Again, equivalent fractions, the idea that 5/45 is the same as 1/9. Multiply denominator by 9, so we multiply numerator by 9. 18/45 is the same as 2/5. And then we can add those together, and we can see that 23/45 of this bag is not soil. Of course, the question that what I was asked here said, what fraction of the bag is soil? How am I going to get that? And you can tell me what the answer is, but perfect, Courtney. That's it exactly. What fraction of the bag is soil? Well, the entire bag, 1 whole bag would be 45 45ths. I'm just rewriting 1 as a fraction that has a denominator that comes in handy in this particular problem. And so there's 1 whole bag, that's 45 45ths of a bag. If I subtract the 23 45ths that is not soil, that'll leave me with 22 45ths, and that is the fraction of the bag that is soil. Pretty close to half, but not exactly. So first we just added those two together to figure out, okay, how much is not soil? And then I'm going to subtract that from 1 to find out how much is soil. Any questions on what we did there? All right, outstanding.